Hello, this is a short video regarding the introduction of classes in C, C++ or in C++. Until now you have been using functions. For instance, to switch motors on, you could create several different motor functions, and in this case I created three functions that we called like this: motor 1 on, motor 2 on, motor 3 on. This is regarding usability. Is it a little bit unusable? Because if you need, for instance, another function like motor 4 on, then you have to create a new function which is a copy of motor 3 and then adapt what you need. Now, of course, we could make it a little bit more clever, and one of the things we could do was this. For instance, we define a new function, and then instead of a motor 1 on, we can say motor on do 1, do 2, and do 3, for instance. Then we use the same function, and depending on the past number we could act what we need. But still, again, if we had a fourth motor, then we would have to do things like this. Oh, that's wrong, I see, but doesn't matter. It should be 3, of course, and this is 4. So if you add something, then you have to manipulate the code in this way. And we could think of other constructions, and depending on some drivers we could make it simple, but the idea is that in the end normally you would have to add extra code to add extra motors in this case. Well, it would be nice if there's another possibility to preserve functions and make things a little bit more general. And that's why I made this overview. And this overview tells us that we would like to have the capability to keep things together for a certain type of item. Well, let's look at the left hand here. We can describe the properties of a car, and we want to keep them together, and in this case it's in a block, of course, or in a square, and it tells us that the car has 4 wheels, 4 doors, it has a motor, for instance a gas motor or gasoline or diesel, it has 4 chairs, and it has headlights, and it has backlights. And the description of what we see here is what we call a class in C++. So a class describes properties of a certain thing, and in C++ we also have functions which we call methods that can execute things within the class. But I'll show that later. Well, if we have a description of a class, then it's possible to create an object of that class or an instance of that class. And in this case we could say, okay, I create a BMW 318, which is a car, and that car has 4 wheels, 4 doors, it has a motor, gas or diesel, it has 4 chairs, headlights and backlights. And the same if we create an instance of this car, which we call an Opel Astra. It still has the same properties. S has a Volkswagen Passat, S has an Audi TT, but the exact implementation of these things might differ. They're all cars, they all have 4 wheels, but for instance an Audi TT has light metal wheels and all the others have default steel wheels, or the motor might differ. A BMW 318 and an Audi TT might have stronger motors than a Volkswagen Passat, which has a stronger motor than an Opel Astra, for instance. But they all still have headlights. But the headlights of the Opel Astra might be simple, what are you called? Lights. What's it called? I don't know, and an OutDT has default LED lights for now. So we are creating different objects of the same class, and the values of the properties in this case might differ. Well, the same principle applies when we are going back to our C++ environment. Here we can also create classes and create different versions of a object. So what are we doing? We can then do things like the following. I'm taking an example and I'm taking in this case some LEDs as an example, and then our code is going to look a little bit like this. First of all, we have to we have to include a header file that describes our class, which I'll show later, and then the information is available about the class CLED, and we can create an instance like we did of that class, like we did here where we created a BMW. Then I can create an instance called LED1, an instance LED2, and an instance LED3, which all are of type C class, and they contain in this case functions, methods, and the LED class CLED has an on and in this case an on function, which I can use to switch a LED on. Well, how does this construction look like? As you can see, we have a header file, which you learned last week how to use them in combination with C files, but now we are going to use them in combination with CPP files, which are C++ files. Let's first go to the LED.h implementation. We define a class by the name class, and then we specify a name, and we are using C underscore to indicate that it is a class. So it says class LED, and opening brackets, closing brackets, and the semicolon, don't forget it. And we are using an on function and an off function. The on function doesn't take parameters and it doesn't return anything, and the same for the off function. And I have two variables, see it like properties over there. A variable is off and a variable is on, and I make them public here, and I'll show later what it means. But what it says here, every instance that I create of CLED, so our LED 1, 2 and 3, they contain two functions and they have two variables. Then the functions have to be implemented somewhere, and these are going to be implemented in the LED.cpp file. Well, again, here, the compiler needs to know if the implementation of this function is okay, and for that we include the LED.h, so this one, which describes to the compiler, okay, we want to create a class, it's called CLED, it has some public variables, and it has two functions. And for now, we are only implementing one function, which is the off function. And as you can see here, this is the description of how we are going to use it. And until now, in C files, you used this construction, void of void. There is a function in the system which doesn't accept anything and doesn't return anything. But to make it part of a class, we put our class name in combination with the double colon in front of it. Now it's a function of that is part of our CLED in this case. So that's what I did here below. I'm creating a function of which doesn't accept anything, doesn't return anything, and it is part of our CLED class that we described in the header file. So, and what does it do? When this function is called, its setting is on to false, is off to true, and it prints some information. Well, that's the basic rule for now. Let's build it. One error still. CLED on. Yeah. That's not very clever of me, of course. Let's make the on function in this case is on is true, is off is false, and the let is on. Okay. Now it's okay, and we can go to the debugger. And we can use our watch window as we are used to, and here you see that I can use this variable as normal, the instance in this case, let1, let2 and let3. And what you also see is that let3 is not being used, so it's optimized away. And here we see that we have a let1, which is of class CLED, and the same for let2, and its two variables are both off or 0 in this case. Let's step through it, and then when I enter let1.on, we are entering the code which is in let.cpp, and when we step through it, we see that the is on is being set, and also our printf has executed let is on. And if we do the same for the second let, it runs through it. The second print has executed, and we also see here that is on from let2 is on. So that's a way how we are creating instances of a class, and we can call the functions of the class to execute something. Hold on. Let's go back. What I did is that I said, okay, these variables, where are they? Here are public, which means that I can use also from here. So because the variable is off and is on are public, it means that when I'm using an instance, I have access to these variables. Like I also have access to the on and the off function. And that it works, I can show you very quickly. Go to the debugger, and I open them, and I simply step over it. And here I'm now trying to set this is off from let1 to true, and as you can see, it sets the value to 1. Well, that's not desirable, because the implementation here on of CLED should use these variables to keep track of whether it's on or off at a certain moment in time, which means when I called on as last, then of course this should be on a true and its off should be false, and if I call the off function, it should be the other way around. So basically, it's not the idea that I'm messing around with internal information, the variables of that one, that I can manipulate it at this level. It should only be manipulated by the on and off function. Well, to do that, we are making the functions still public, and we can make the variables that we work with, we can make them private. And as you can see, the editor is already complaining and says that isOff is a private member of CLED, which is true because we made it private. And also when we rebuild it, it will complain here that isOff is private, declared private. It says it here, a private member of CLED. So that's here, and it says it's declared over there. So we're not allowed to use the internal variable. For the rest, if I remove it, I can still build it. And enter the debugger and execute what it should do. As you see, the on function should set this variable on, and of course the print again. And if I need an extra function or an extra object, sorry, that does the same, I can add 3 dot, and then we already see here the on function. And right now I have 3 objects that I can use, and as you can see here, now let 3 is also known with the same variables. So the moment I want to add an extra function, I add it to the class. First I add, of course, here an extra public function. I implement it then in the CPP file, and from then on I can use it in main, but I can use it for all 3 instances in this case. Which also means that if I made an error in a function here, that I only have to update or change it once in this code, and then it's available for all the 3 LEDs again. Well, that's the basic idea about classes. So we have a description of what's private and public and the name in the header file. The functions have to be implemented in the accompanying CPP file, and we have to include the header file, otherwise the compiler doesn't know which functions have to be prepared. And at the level where we use it, we create an instance of a class as much as we need, and vervolgens can we use the functions that are available or public variables simply by typing the name dot and then accessing the function. Well, that's it. Thank you for looking, and we are going to use it in the next lesson during the assignments. Thank you.